So this is the 612 unit review, and we've crossed out all of example 1, and we've crossed out example 2, B, and C. So I'm going to put up 2A right now. So if the bases are the same, you can set your exponents equal to each other. Oops. Sorry, let me get it in focus. All right, so I need to set 2x plus 1 equal to 3x minus 4 and solve for x. This is a terrible color. So I would add 4 to the other side. So I've got 2x plus 5 equals 3x. And then I'm going to subtract the 2x to collect the x's. So it looks like x is 5. Did people get x is 5? Okay. So then number 3, this was like our day 1 set of notes, plugging in values and evaluating. So I'm going to get 2 times, this is just going to be 5 to the 0 power, right? 2 times 5 to the 0 power. 5 to the 0 power is 1. So I just get 2 minus 3 is negative 1 as my final answer. Is that right? And then the second one, I'm going to do the 5 squared, right? So 2 times 5 squared minus 3. So 2 times 25 minus 3. 50 minus 3 is 47. So we did okay on evaluating without a calculator. Order of operations. That's one I definitely want you to be able to do, order of operations. Yeah. I'm going to start with A. So I'm going to do the parent function first because I'd like you to be able to make a table of values for x to be negative 1, 0, and 1 for any of the parent functions. So if I plug in negative 1 to any parent function, it just takes the reciprocal. So 2 would become 1/2. And then we know that the y-intercept is always 0, 1, because anything to the 0 power is 1. And then 2 to the first power is just itself 2. This is called the parent function, those 3 key points. So what I like to do is plot my kind of parent curve. There it is. I just kind of sketched the red curve in lightly. The red curve never goes below this asymptote. So this asymptote is sitting at y equals 0, and I can't go below it. So now when I shift my graph, what does this plus 4 do to the graph? So you might have to look at your transformation rules, but plus 4, a big plus 4 goes up actually. You're right if it had been x plus 4, but if it's a big plus 4, the whole thing is getting shifted up. So up 1, 2, 3, 4. So just move all of your points 1, 2, 3, 4, 1, 2, 3, 4. Your whole graph should shift up 4, and so should your asymptote. So your asymptote should now be at y equals 4, and that's going to affect your domain and your range. Okay, so what's my domain and range for this function? Domain is always all real numbers because the graph goes forever to the left and the right, but my range starts at that green line and goes up. So how do I write my range? And you don't need the equal to. Y cannot touch the line. The line is like the barrier, so y is strictly greater than 4. So let's do the same thing on example 4b. So let's make a table of values first. So plug in just for the 1/4 part, negative 1, 0, and 1, and graph the parent function and then do the transformation. So this time it's a fraction, it's decreasing. When I plug in negative 1, it takes the reciprocal of that fraction and actually gives me positive 4. Anything to the 0 power is always 1. And then anything to the first power is just itself. So 1, 1/4. So if you didn't get a chance to graph this one yet, graph those 3 points yourself. That's your parent function. So this is called exponential decreasing. So there's my red parent graph, and remember that's sitting here at y equals 0. What does this -2 do as a transformation? This one moved up, right? The big +4. So this is actually in the exponent. It's a little x minus 2. So what would that do? It actually shifts it left or right. Right by 2. And those transformation rules, you want to make sure you have them filled in so it's a resource to look at. So there's right 2. My asymptote has not changed. My asymptote is still sitting right there at y equals 0. So now the green curve, what's its domain and range? What'd you say? Domain for any exponential is always all real numbers because it can go forever to the left and the right. But I'm starting at this green line and I'm going up. So y is strictly greater than 0 is my range. To make sure you have the help maybe that I could try to give you. So let's see, exponential, the base is 4, so that's 4 to the x. It's been flipped over the x-axis, so I need to put a negative sign in front of it. And then if it's been shifted to the left, I actually think, oh, we did right over here, didn't we? So the left is going to be a +5 this time. And it's little up in the exponent with the x. And you need to be able to look up a transformation rule and write a function. This time the base is 1/2, so 1/2 to the x. And it's been shifted up 2, so that gives me the big +2 after the function. And if it's flipped over the y-axis, it actually gets a negative in front of the x itself because all the x's are getting flipped to the other side of the graph. So in front flips it over the x-axis, and up with the x flips it over the y-axis. And then I'm hoping our exponent rules, because I did those with you, literally Monday, Tuesday, Wednesday, we should be really strong on this. So I have these 2 parentheses, but I have got nothing to distribute. So I'm just going to ignore the parentheses. 2 times 6 is 12. And then a total of x to the 9th power, because you add up the exponents, and a total of y to the 2nd power, because you'd add up those exponents. Y is 1 and y is 1. So when they're next to each other, you're going to add the exponents together, but you still multiply the coefficients. On example B, you have to distribute the 2 into the numerator, and when you distribute an exponent, you multiply, and you have to distribute it into the denominator. So right now I have x to the 6th over x to the -16th, and I don't want to leave any negative exponents. Negative exponents are unhappy where they currently are. So I'm going to slide this up into the numerator and make it a happy positive exponent. So now I have x to the 6th next to x to the 16th, and I can add them together for the exponents. So yeah, my total final answer would be x to the 22. So if you did that, you just did 3 exponent rules in one problem. You did the negative exponent rule, the distributive power, and that product rule all in one problem. So that's a good one. To me, that's not an overly difficult problem, but it relies on those 3 exponent rules being used correctly. And then the last one on C, anything to the 0 power is 1. So I'm just going to cross that out so I'm not looking at it, because 1 times anything is itself. So y5, y7, I can add those exponents together, so I would have y to the 12th. Does that make sense?